In this lecture, you'll learn how you can implement events and event handling in a small game. This game is called Fish Revenge because the fish actually eat the bears in this game, and that's not how it usually works out for fish. Let's go take a look. Here's the game that we'll be playing, and I have a fish that I drive around the screen picking up teddy bears with the head of the fish, so the fish is conceptually eating the teddy bears, and as I eat each teddy bear, I gain 10 points in my score. Let's see how the game works in practice. So I can drive my fish, and I can eat a teddy bear, or I can push him around, but if I can eat him with my head, I get 10 points, and so on. And I just keep scoring more points as I eat. Let's take a look at the code to see how this functionality is implemented. We'll start with the HUD class. So the HUD has a reference to the score text so that we can change the text, and it keeps track of the actual score as an int as well, and has a string for the score prefix, so every time we display the score, we can put that prefix before how many points the player has. In the start method, I go find the game object with the score text tag, and I've tagged the score text object with that tag, and I get the TextMesh Pro UGUI component attached to that game object, and then I can set the text to score prefix concatenated with the current score, which at this point is 0, because that's what the score is when I start the game. I also have a public static method called addPoints that has a single points parameter that says how many points are getting added. And when this method gets called, I add the points to the score, and I change the score text to show the new score. If I right-click Add Points and say Find All References, I can find out that within the fish, I call the HUD Add Points method with bear points, the number of points the bear is worth, here if, in fact, I've collided with the head of the fish. And of course, I destroy the teddy bear when that happens as well. So this is the current implementation. We have a static method in the HUD class that lets consumers of the class add points, and here in the fish we actually call that static method. What we don't like about this implementation is the fish is just a game object that has fish behavior. It shouldn't know that it fits into a bigger game that has a HUD. It should just know that it's a fish and that it can eat teddy bears. So we want to change this so the fish doesn't have to know that the HUD exists or that it has an add points method. The way we're going to do that is we'll use an event. Remember from the Unity event documentation that we have a Unity event with no parameters and a Unity event with one parameter and so on. And this is actually the Unity event that we want to inherit from, because this Unity event has one parameter and we want to pass how many points we want to add to the score. So this is the version of the Unity event we want. And you should notice that it says if you wish to use a generic Unity event type, you must override the class type, which means that we need to define a new class that actually inherits from this class, providing between the less than and greater than signs the data type of the information that the event will pass. We'll do that by coming over here to the Unity editor in our scripts folder. We'll create a new C# script, and we'll call it points added event, and we'll open it up. This is our standard template for a new script. I'll say this is a points added event, but we're not inheriting from MonoBehavior. We're inheriting from the Unity event generic that has one parameter. When I start typing Unity event, though, we don't get autocomplete for Unity event, and we can see from the Unity event documentation that this is a class in the Unity Engine.Events namespace, and we don't have a using directive for that namespace in our points added event class yet, but we can easily fix that. We'll just add that using directive. And now we can get access to Unity event, and this is going to be an int because our points will be just an integer. Because we don't inherit from monobehavior anymore, all this stuff goes away. Now you might wonder, so we have a class called pointsAddedEvent, but it doesn't have any methods, so how is this useful? But it inherits from UnityEvent. And UnityEvent has some useful methods that we'll use to hook everything together to set it up so that we have a class that invokes the event and a class that listens for the event. The class that invokes the event is the fish class. So I know I'm going to need a using directive for Unity engine .event. And the way I do this is still score support, but I need an object that's a pointsAddedEvent object. So pointsAddedEvent. And pointsAddedEvent is a new class that we've just defined. So this is a data type. We just provide the name of the variable, or field in this case. And this is one of those cases where we're using pure C# to get a reference to a pointsAddedEvent object. So we call a constructor for pointsAddedEvent. And I'm just hitting tab to complete the rest of this. Okay, so we have this pointsAddedEvent field. We're going to have to do two things with the field. We're going to need to change our code somewhere so that we actually invoke this event. But before we do that, we're going to change our code to make it so that a consumer of this class can actually add a method, a UnityActionDelegate, as a listener for this particular event. So I'll go add some of that code and we'll come back. Here's the method I added. So it's public because a consumer of the class, external to the class, needs to be able to access it. It returns void. I called it add pointsAddedEvent listener as the method name, and it has a single parameter, UnityActionInt, and the parameter name. So this data type has to match the event that we defined. And the event that we defined has one int parameter, so this does match the delegate for a listener for that kind of event. Now I need to actually add it as a listener to our event field, so I say pointsAddedEvent dot, and as I said, we inherit some methods from UnityEvent, and it turns out that add listener is the one we want, and in fact this is a great suggestion, so I'll just tab and take it all. So we're not invoking the event from this class yet, but we are making it so the HUD can add itself as a listener. So over here in the HUD, in our start method, add self as pointsAddedEvent listener. The first thing we need to do to be able to do that is get access to the script that's attached to the fish game object. So that's data type fish. I'll call it fish script. So first we find the object that is tagged with the fish tag, and I had to go back and add a fish tag to the fish. But I know I called it fish. And if we do this, we're holding a game object. So now we can get the fish component that's attached to that game object. So at this point, I'm holding a reference to the fish script. So I can call the add pointsAddedEvent listener, and I'm going to add points as that listener. The compiler is letting me do that, but we can clean up add points a little bit here because it no longer needs to be static. Nobody external to this class will be calling this method directly. And really that's it for cleaning up the add points method. But once we do that, we can actually come up here and make our score text not be static anymore, and we can make our int not be static anymore. Those had to be static because we were accessing them from within a static method, the add points method, when it was static. But since that method isn't static anymore, we can just now make those instance fields or instance variables instead. So we'll try to compile at this point, and we've discovered over in our fish class that we can't call the HUD.addPoints method anymore because it's no longer a static method. And that's okay. We didn't want to call it anymore anyway. What we wanted to do was invoke our event. So I'll get rid of this. And it turns out that one of the other methods that we inherit from Unity event is the invoke method. And we know we said we would provide one integer argument when we invoke the event. And that is still bear points. So now I can compile successfully. When I come back to the game and play it again, we can see it works exactly the way it did before. Let's see if I can actually eat that fish, and I did, and the points get added, but it's not because the fish called the HUD.addPoints static method, it's because the fish invoked an event that the HUD was listening for. Let's actually take a couple minutes and use the debugger to watch the sequence of things that happens when the event is invoked. So I'll set a breakpoint here where I'm invoking the event, and in the HUD, I'm going to set a breakpoint here, and I might as well come back to the fish and add a breakpoint where I'm adding the listener as well. So when I attach to Unity and run my game, we immediately hit this breakpoint in the fish, and I'll step because it was getting called here in the start method of the HUD. So the HUD is being added to the scene, and it's doing all the stuff in its start method, and it called the addPointsAddedEvent listener method and added the addPoints method as a listener for the points added event. So now we've hooked the addPoints listener method into the event, and if I keep running the game, and hopefully I can eat a teddy bear quickly, we can see that the fish detected a collision with the head of the fish and the teddy bear. So it's invoking the event, and if I step into this, you see that it's calling the listener that registered itself to hear the event. So it called this listener. In this particular example, we only have one listener, but we could certainly have multiple listeners for particular events, and the event will call each of them. It will call every single one of the listener methods that have said they care about this particular event when the event is invoked. So I can just F5 now. Of course, I get to this breakpoint, and then we come back to our game. Now, the more astute learner may say, well, you made it so the fish doesn't have to know about the HUD anymore, but the HUD now has to know about the fish. So how is that a win? Well, that's kind of true. It's okay for the HUD, which is sort of a game level thing, to know about the game objects in the game. That's better than the game objects having to know about the HUD. But we'll actually fix this in the next lecture, where I add something called an event manager so that the fish doesn't have to know about any of the game objects in the game, and the HUD doesn't have to know about any of the game objects in the game either. But the good thing from this particular lecture is that we replaced that static method and the fish having to know about the HUD with our first event that we add a listener to and invoke to keep the same functionality, but with a better object-oriented design. To recap, in this lecture you saw how we could refactor a static method that let the HUD add points to the score to use an event and an event handler instead. And this is a better object-oriented design, but it's not great. But you shouldn't worry, because we'll do better in the next lecture.